So for this section, you're still simplifying, but you're simplifying in, where you might not necessarily have the exponents that you need to come out nice and evenly when you divide. So we've got 5 square root of 16, m to the 6th, n to the 7th. So the 5 here is just being, it's like 5 times the square root. So the 5 is just going to stay. And you can add a parentheses if you want to, so you can remember to multiply. So 5 square root of 16, the square root of 16 is 4, so that one goes away. And some of these, when you start doing these, they get longer and longer. It gets harder and harder to keep track of. So if you want to just cross it out, that's fine to help you. For m to the 6th, again, there's a 2 here. 2 goes into 6 3 times, so that one does come out evenly. So that would be m cubed. And that takes care of our m to the 6th is taken care of. For n to the 7th, though, 2 goes into 7 3 times, and you've got 1 left over. So you're going to still have an n in the square root. So some people also do this. They break it into an n times an n. And what's the smallest exponent that 2 will go into? Not the smallest. The largest exponent that 2 will go into is they'll say this is n to the 6th times n to the 1st. Which if you want to do it that way, that's fine, because then you have square root of n to the 6th. 2 goes into 6 3 times, so n cubed. And so this is gone. And you still have the square root of n left. Now, I don't normally do it that way. I normally don't write that down. I think I did on the notes just because some people do this. Because for me, what I do is 2 goes into 7 3 times, so you've got an n cubed, and you've got a remainder of 1, so there's still a square root of n. So however you want to think about it, if it helps you to write down n to the 6th times n to the 1st, because that is n to the 7th, 6 plus 1 is 7, then that's fine. Or you can just do it if you have a remainder, if it doesn't divide evenly. So however you want to think about it. And then the last thing, 5 times 4 is 20. So this would be 20 m cubed, n cubed, square root of n. So the next one, it has square root of 2/7. You're not supposed to have a fraction in the square root, and you're not supposed to have a square root in the denominator. Square roots in the numerator is fine. So when you're dividing here, you can split that up as the square root of 2 divided by the square root of 7. So if you have this, you could write it as one fraction in the square root, or if you have a fraction in the square root, you can split it into 2. Those are equivalent, but like I said, you're not supposed to have the fractions in the square root, and you're not supposed to have a square root or a radical in the denominator. So the way you get rid of radicals in the denominator is if you just have a single radical, you multiply by the same radical. And whatever you do to the bottom, you have to also do to the top. Because what that does is when you do the square root of 7 times the square root of 7, when you're multiplying radicals, you multiply their insides. So that would be a different color. This would be the square root of 7 times 7 is 49. The square root of 49 is 7. So essentially that just takes the radical away. So you'd have square root of 7 times square root of 7 is just 7. So that would be your denominator. And then to multiply the square root of 2 times the square root of 7, you just multiply the insides. 2 times 7 is 14. So you'd have the square root of 14. And then you could simplify that if it's simplified further. Square root of 14, there's no perfect squares in 14 that you can take out. So you're just done. So rather than having this form as an answer, if you ended up with it, or this where it's separated, you would write it this way, because you're not supposed to have the radical in the denominator or the fraction in the radical. So that one is just with numbers. So this one, you have the square root of 49 x squared y to the 5th is e to the 9th, all divided by 25, a cubed b to the 11th. So again, you can simplify this in pieces. So basically you're going to take the square root of each piece to start with and see what's left, and then you'll have to, if you've got a radical left in the denominator, you can multiply and get rid of it. So we're going to take the square root of 49, square root of x squared, and so on. So what we're going to do is we'll have the square root of 49 is 7. Square root of x squared, let me cross these out as I go. Square root of x squared, 2 goes into 2 one time, so it's just x. And so the x squared is taken care of. Square root of y to the 5th. Y to the 5th, you have 2 goes into 5 2 times. And then you would have 1 y left over. So you would have y squared. And if you wanted, you could make that a 1, because this out here is a 2. So 2 goes into 5 2 times with a remainder of 1, if you wanted to do it that way. Or you could do y to the 5th is y to the 4th times y, if you prefer thinking of it that way. Square root of z to the 9th, 2 goes into 9 4 times, and you'd have still 1 left over. So we would have z to the 4th, and then what we have left is the square root of yz is still left in there. And again, if you would prefer, you can think about the z as z to the 8th times z. So 2 goes into 8 4 times, so there's that, and then you still have the z left. Whichever way you want to think about it. All divided by, because remember, square roots, or for any radical, you can do the square root or cube root or whatever you have, the nth root of the numerator over the nth root of the denominator. So that's basically what we're doing here. So we got the square root of 25 is 5. So 25's gone. The square root of a cubed, 2 goes into 3 one time. So you're going to have an a, and you'll still have 1 left. Let me switch colors because I don't do too much red. So you'd still have 1 left, or again, you can think about it as a cubed is a squared times a. And so the a squared, square root of a squared is just a, so that's, and then the a's left, or whichever. And the square root of b to the 11th, 2 goes into 11 5 times, so you'd have b to the 5th, and there would still be a remainder of 1. Or again, you can think about it as b to the 10th times b. So the square root of b to the 10th is b to the 5th, and there's still a b left. So what we still have left in the radical here is an a, b. So that's step 1. Basically just take the square root of all the pieces and see what's left. So this one, the numerator is fine. The problem is the denominator, because you're not supposed to have a radical in the denominator. So to get rid of the square root of AB, same thing as we did here, you're just going to multiply by the square root of AB. And if you multiply on the denominator, in the denominator, you have to also do the numerator. So you're going to be left with 7x y squared z to the 4th times the square root of all this. Square root of yz times the square root of ab is just the square root of yzab, or however you want, whatever order you want to write it in. If you want to put ab first, that's fine. It's multiplication. All divided by 5ab to the 5th times, so here square root of AB times the square root of AB is going to work just like this. Basically, square root is just going to go away. You're going to be left with AB, because what you end up with is the square root. A times A is A squared. B times B is B squared. The square root of A squared is A. Square root of B squared is B. So that's why that works. So times AB. And then you can put these together. A times A is A squared. So the numerator is the same. Let me go down one more. Got 7xy squared z to the 4th square root of YZ AB, all divided by 5. A times A is A squared. B to the 5th times B is B to the 6th. So for these, just remember you're not supposed to have that radical in the denominator, so make sure you multiply. And I think for this one, they generally give you square roots. If you have a cube root, you can't multiply by just the cube root. You have to multiply, because a cube root times a cube root doesn't actually go away. You'd have to do it twice. So if you had a cube root, you'd have to multiply by other things to make it go away. But I think you should only ever have square roots for this class, unless I remember incorrectly. But for this class, I'm pretty sure we're only doing square roots. So all you have to do is multiply by the square root to make it go away in the radical.